Thank you all for coming out tonight. It must have been a temptation to sit in the garden or do something else, but I am already sweating slightly and I haven't even started talking yet. So I'm going to talk a little bit about building applications with GitHub Copilot, and I shouldn't think we'll be longer than about 8 o'clock. Is it? Oh, you're following me. Now I was going to stand right over here. I was going to stand out here, actually, where it's a bit cooler. This is actually part of the season of agents, which is this season 4 of the season of AI that Microsoft's doing. And they had 4 pre-built talks. And we're doing this one, which is building applications with GitHub Copilot agent mode. We missed that bit off the end of the title of the talk, but it's kind of agent mode is where we'll end up. But when I looked at this talk, the material they'd prepared for it, it was using the Bongo database and the jammy front end something or other. And so I thought, well, if it's a .NET user group, probably we should focus on more on sort of .NET stuff. So I will focus on Visual Studio. I will use Visual Studio Code a little bit, but I'll do quite a lot in Visual Studio and using GitHub Copilot in that. Anyway, my background is I'm work mainly in Microsoft 365, and I also do Azure AI. Those are my topic areas. But as you can probably guess, I've been doing software development for quite a long time. And it used to be, a long time ago, I was doing Fortran, and we'd have really bad practices. We'd have 10,000 line Fortran files that we'd work on, and then you'd keep a backup copy of it. That was source control. You'd have a backup copy of the file on a tape, and you'd print out a great wodge of line printer output and work on that, and then you go to your glass teletype. And you'd think things would be easier now for software development, but they're not, because they've just actually got more and more complicated. So I've got to the stage where my brain can't really hold all the different frameworks and different languages that I have to use and different platforms in some cases. So this is really a godsend for anybody whose sort of brain is now at overload. We can offload a lot of this into GitHub Copilot or other AI assistants for software development are available, but I'll concentrate on GitHub Copilot. So I'll talk a little bit about how neural networks have got us to this point where we can do this. We'll talk a bit about coding assistance, code completion, and then we'll look at chat mode and then agent mode, which is the main thing. And then we'll just quickly discuss whether we're all actually completely doomed as software developers. Now, this is a slide I used to use in around 2017, and the story there was, oh, look, AI is really developed to the point where it's actually useful now, because it hadn't been and AI, by the way, has been around since the 1950s, although you hear so much rubbish talked about AI, artificial intelligence, but it's been around since the 50s, but it's been through several cycles of failure and reinvention, and it really only like 8 years ago that it was actually able to do anything useful with it. So we could do things like speech recognition and image classification and machine translation. It got to the stage where they were kind of below the 5% human error rate level, which suddenly they become useful. You know, if you've got 60% accuracy with your speech recognition, it's completely useless, which was the case in 2011. But by 2017, it had got usable. And we could, this was because we had much bigger computers. We could use the cloud for burst compute power. We had sources on the internet of large amounts of images that were all labeled, so we could train models. And we had these very deep learning models, they're deep neural networks. So most of the interesting stuff in AI is using neural networks, and they've become very, very powerful. So again, back in 2017, you could use Azure AI Vision, and showed a picture of New York, and it would say, oh yeah, it's a black and white photo of a city. You know, it'll produce some text that described the image. And that was great. That was very useful. If you've got 10 million images on a hard drive somewhere, and you want to, and nobody bothered to tag them, you can just throw this at it and tag all the images, because it was too expensive to have people going through it. So that was great. Here's another deep neural network, just for comparison. This is actually the brain of a fruit fly, which is this tiny little fly. If you've ever done biology at school, you might have bred fruit flies, because they have a very rapid, you know, one-day life cycle or something, and you can do genetics with them and things like that. But the brain is quite small, tiny, of course, and they've been able to map it out completely. And it's quite interesting that they discovered some techniques that have been independently developed as part of the sort of computer vision AI research, with skip layers and layers folding back on each other and things like that. And they see evidence of this in this actual physical brain. Of course, all of this has been made possible because they've used AI to help them map the complete connectome, is the word they use for it, of all the individual neurons and the axons, and how they're all interconnected. So they can map it out and figure out how it works. And that's about 130,000 neurons. So we can do a little comparison between ResNet 152, which is the breakthrough computer vision model that eventually, you know, Azure AI Vision was developed from, had about 130,000 of these artificial neurons, which is about the same number as a fruit fly brain. The synapses in a fruit fly brain, that's the connections between the different nerve endings, is about 50 million. There's about 60 million of these weights, the parameters in this neural net for ResNet 152. Slight differences though. So in the case of a biological brain, it has a few other tricks, like it can change the wiring on the fly, as it were. It can remap the connections, which you don't normally do with a neural network. Usually you set the architecture up and then you train it. These can change, and they can use neuromodulators like adrenaline and things to change its behavior, which we don't normally do. So it isn't quite a one-to-one mapping, but it gives you an idea of these, and this is, you know, back in 2017, the size of these was about equivalent. So we had AI models that were kind of fruit fly brain sized. So that's quite a big leap to go to a human brain, which has about 100 billion neurons and 100 trillion synapses. It's about 6 orders of magnitude. It's 1 million times more complicated than a fruit fly brain. So we can't really expect to do any sort of thinking with a model of this sort of size. But some of the newer models, which we're going to look at in a second, are kind of moving a bit nearer to this sort of size. They're still an order of magnitude or so small, or two smaller, but they're kind of more at that sort of scale, so we can kind of do more with them. So the breakthrough paper was actually in 2017, when we were all congratulating ourselves on these things like AI vision being able to identify New York, the New York skyline. And it was actually a paper from some Google engineers called "Attention is all you need," and that introduced the transformer architecture, which just changed everything. So in about 2017, this new deep learning architecture, one of the key things about the transformer architecture is it's parallelizable. So you can throw it at things like GPUs and train, and also use them for inference as well. So it becomes much more practical to make much bigger models. And also for things like natural language processing, they have a kind of a bigger reach, so they can take a much longer string of text and connect things that are sort of the extreme ends of it and connect them, which was a limitation of the preceding technology, which was called recurrent neural networks, and they just could not cope with very long strings of text. They were limited. And the attention mechanism that they talk about refers to, where you focus on a particular word and how it relates to other words, because words have different meanings depending on context, and that's the key to natural language processing, is being able to relate words to each other and focus on the right bits. And so these transformer models were very good at that, and there was just a huge breakthrough as they trained larger and larger models. They were able to do really interesting things like, for example, predict text. So that's just one of the things. A transformer model was originally for text translation, so there's an encoder and a decoder. There's two halves. So normally for text translation, you'd put language in put text in one language into the encoder. It would go through, be encoded into the sort of the internal representation, and then decoded. But if you just take the decoder of this model, you can actually do something called completions. So you do generative text generation, so it's generative AI. And what that does is it says, well, if I've got the quick brown fox jumps over the lazy dog, predict the next word. That's all it actually does. So it says, and, that might be the highest probability word to come next. And then it just does it again and again and again, word by word by word, just takes what I've got so far, what's the next word? Given that, what's the next word? Okay, given that, what's the next word? And that's all these large language models are doing. But they have some sort of inherent understanding because of the way they're trained and because of their size. They kind of have an understanding of what the text means at some level. And so you can do some tricks, like you can prompt. So you can give it a string of text, say it was a dark and stormy night, and it will go on and make a whole novel about starting from it was a dark and stormy night. And if you say JavaScript function to reverse a string, function string reverse, open curly brace, there's a good chance that it will return with something like this, which is a function that will reverse the string in JavaScript. And you might think, why isn't it just string.reverse? You might think, why is that? But it knows somehow that it can't do that because the reverse operates on an array. So it has to convert to an array, reverse it, and then turn it back into a string. So it's got this sort of, somehow got this understanding, even though all it's really doing is predicting the next character. With something like ChatGPT, which was the sort of the first point where everybody suddenly became aware of these large language models, that was achieved by a lot of, not just this training a model. So there's the pre-training where it gives everything on the internet and GitHub and Wikipedia and Archive and Stack Exchange and puts that in and trains a model with that input. That doesn't give you a useful large language model, let alone a chatbot. You have to do more work. So you have to have hundreds of contractors that then look at inputs and outputs and say, this is a good input that would correspond to that. This output would be good for that input, and then train it on that. So they do some supervised fine training, and then they look at the outputs and say, okay, that's a good one, that's not so good, that's not so good, and ranking them. Again, more tens of millions of dollars spent on just people training these models. So part of the skill is all this, which gets you a good large language model that's good at predicting the next string of text. And then on top of that, you have to build all kinds of mechanisms around it, like the memory of what went before in the chat. And you probably want to do something like some prompt engineering to sort of queue it up to like a system prompt that will be with every response, it'll with every request, it'll add a system prompt, and then it will add the user's prompt. And so there's a lot more to it to build a chatbot like ChatGPT, and that's the skill of people like OpenAI who build these models. So a lot of people went on to ChatGPT and discovered that, hey, it wasn't so bad for generating code, slightly surprisingly. But then you think, well, it's been, amongst all its training data, is a lot of code that it can see on GitHub and places like that, and Stack Overflow. So some people started using ChatGPT and using that to generate code. Write me a function that does such and such, or take this function and make it better. The risk there is some people got into trouble because they actually lost intellectual property leaking out, because when you're uploading something into ChatGPT, it's not private. You know, they then use that to train their models and make them better. It's one of the ways they do it. So a better option really is to use something that's specifically for code generation and that's also private. You know, there are some guarantees around it. So maybe you have to pay a little money, possibly, to get that. So coding with a large language model. So we start with the large language model. That's the sort of the engine behind it. But there's quite a lot that's built around that to build something like GitHub Copilot. So it will have memory of the conversation you've had before, so it's keeping a track of the conversation. There's some prompt engineering. They don't always tell you what the prompts are. Sometimes that's proprietary. There's also some instructions that you might add. We'll see how to do that in a few minutes. We'll need to know the contextual information about what else is in your project and what other files you have open, for example. That's a good indicator. If you've got a tab open in your IDE, it's a good indicator that that file is important. And so it will take all that information and it'll do things like, well, usually this is called RAG, Retrieval Augmented Generation, where you take some relevant content and include that in the prompt. So the prompt that's sent to the large language model will be whatever the system prompt is, plus whatever relevant code it can find from the project, and it'll send that as well. And then there's the user prompt, which is, you know, please write me a function to reverse a string. And it'll see, you know, if it's JavaScript project, it'll see it's JavaScript, and if it's C#, it'll see that it's C#. And then one of the other, so there'll be some guardrails as well, probably. And another trick we have is what they call, that's what Microsoft, the GitHub Copilot team called tool calling. I would call it by what I think I would regard as the correct name in AI, which is function calling. And that's a technique in large language models where you make a request, but you also say in the request to the large language model, you say, and by the way, I've got these functions you can call if you want to. And that goes up to the large language model. And the large language model, if it supports function calling, in other words, if it's been trained to do this, which most of these big ones like GPT-4 have been trained to do this, it will say, look at the functions it's got available, and if one of them is relevant, it'll call back in the response. Instead of just giving it a response, it'll say, oh, I want you to call this function with these parameters. And then you call the function, and then you send it back up again. So there's actually two calls involved to the large language model, and then it goes up to the large language model, and now it's, right, I've got all the other stuff plus that the output from those functions, and then it sends the response back, and that's what it gives back as a response. So that's called function calling. In this context, they tend to call it tool calling. So they'll have some tool, like, for example, I can call GitHub and do something in GitHub. So that's where you get the agency from. So you can actually get it to do things as well as just come back to you and say, here's some code, you might want to paste this in. It can actually just paste the code in, or create a new file, or do a pull request, or so it can do more powerful things with tool calling. So that altogether gives you a much more powerful tool, which can do things like, it's good at programming languages. It has a wide range of knowledge of programming languages. It knows a bit about best practices in software development. It can do things like documentation, as much as you want. It's got good GitHub integration. It's got general knowledge, because usually these are using, so originally, in the early days, GitHub Copilot was using Codex, which is a large language model specifically trained on code. But more recently, they've found that really, if you just use a general purpose large language model, they've had such a broad range of training data that it's all in there, and so that's sufficient. So you tend to use these general purpose large language models rather than one that's specifically for code. But there might be some small language models for doing specific jobs that they use inside GitHub Copilot as well. So they've got a lot of tricks going on behind the scene. But this is essentially what's happening. GitHub's Copilot not so good at very large code bases. So if you've got a huge code base, then eventually there's a limit to the context window, and you will exhaust that. And so if you give it too much information, that can have a negative effect, as in the same way as not giving it enough information. And so it's sometimes you need to sort of narrow down the amount of information. If you've got a huge code base, you focus it down into the relevant part, or break it down or something. Not good at doing original research, so thank goodness. That's something we can still do. It's not kind of real time. It's responding to your prompts. So you've probably seen this before, but let's see what Copilot looks like in, we'll start with Visual Studio Code. Who uses Visual Studio Code? Okay, and Visual Studio. Okay, so about 50-50, but I think a lot of them were the same. Who uses both? Okay, yeah, so right, okay. So I would say there's about half a dozen people use both, and there's about another half a dozen use code, another half a dozen use VS. Right, I can just move that MongoDB water bottle. Right, so let's open Visual Studio Code. And actually, is it, that's interesting. Yeah, I'm not doing that. Okay, let me just, it takes a while to switch over. So let me just unplug and then plug back in again. That might do the trick. Something's happened? No. Something happened here, so.
I think it might have a resolution, might change the resolution of the laptop. Okay.
Oh, here we go. Oh, yeah. Just takes a while. What we'll do first is I'll go into CD projects, CD AI. Let's make a directory demo 5 or something. 5, and I'll do .NET new console. Right, I'm just going to actually open that from here. So I want to do code dot, still working, isn't it? Yes. Yes, I trust the authors of this non-existent code. Right, so I've got a brand new, get rid of all that. So what I can start doing here is I can say, let's say int Fibonacci. And it's already suggested int n as a parameter. I'll take that. Now what you see is sort of grey text. They call it ghost text, as it's doing completions for me as I go. Now I can switch that on and off. There's if I don't want it, I can make it go away, but it will keep doing. So I can go, yes, I'll have that. Oh yeah, we'll have that. Yeah, so far so good. It doesn't want to do any more actually. So I'll.
Using piece of up.
Oh yes. Control Shift plus. How's that? And we don't really need to know the structure of the fascinating project file structure. So I've everything after Fibonacci is pretty much it's generated automatically. Now, in fairness, it's probably seen this kind of code a lot, so it's not a huge ask. But it's interesting that it immediately knows just from the name of it. Now, we can say console write enter the number. Yeah, that'll do. That looks good. I'm not even looking at this code. I'm just going, I think I'm done actually. Save. Oh, hang on. Has it created else? No, that's just ghost else. And so if I now go here and say .NET Run, and I haven't even checked the code. I barely looked at it, and it should say 20. Anybody remember what Fibonacci numbers are?
Rabbits.
Rabbits. Rabbits?
Ah, well, that's the number of rabbits in the generation. That's what Fibonacci.
Oh, okay, yeah.
I haven't mathematician, so.
Right. Oh, okay, yeah. I didn't actually know that. I didn't realise rabbits were that mathematical. Yeah. Well, like rabbits, they go up very rapidly. So each number is the sum of the two preceding numbers, isn't it? That's, so you start with 0. 0 plus 1 is 1. 1 plus 1 is 2. And then 377 plus 610 is 987, obviously. And so it goes on. Now, you might have forgotten what Fibonacci numbers are. You might have forgotten how to write in this particular language, C#, because I've spent the last 2 weeks in JavaScript. So, I'm getting a bit vague now on what the C# syntax is and I'd have probably started writing function Fibonacci bracket n and then open parenthesis and then gone into the next line or something because I'd have forgotten. But here I'm able to write a Fibonacci series pretty quickly without actually really knowing what I was doing, to be honest. But I can check the results. Is it good code? Looks okay, actually. Let's document it. So if I do // it should generate a... Now, if you wait long enough, it will generate a documentation thing here for you automatically. But it tends to be a little bit on the slow side. But you can say... I don't know, why is it put using system in here? I mean, we are using system, but what I can do here is I can say Copilot, editor, inline chat, and say /doc. Oh, I think I have to press the arrow on. And now it generates a nice little documentation block over the top of it if you need that. And in fact, there's you can set up some instructions for Copilot as well. So you could say in the instructions, every function must have a documentation block above it in this form and specify and put all your coding standards in there. I haven't, obviously, because I just created this. Now I can do the same thing in Visual Studio. So let's file, new project. And we'll do a console app. So they've pretty much got to parity now between Visual Studio and Visual Studio Code in terms of GitHub Copilot. And it's the same engine running behind the scenes. So I'm going to create a console app here, and same sort of thing. I'm just going to get rid of that. I'm going to make that appear in the next demo. So we'll do, what was it, int, brackets, Fibonacci, and we're off to the races. Now this, there is the grey. I prefer this because all the ghost text is actually in the predicted code is grey, so it's clear that it's grey. The way they do it in Visual Studio Code is a little bit more confusing. So if I hit tab, it'll accept all that. And now I can do the console, right, oh, there we go. Yes, we'll have that. That's slightly different to what we had before. That's doing a bit of checking. Oh, it's got some nice if-else here. If it doesn't, if we don't enter, slightly better actually, if we don't enter a non-negative integer, we could test that. Let's run it. So let's say minus 15. Please enter a non-negative number, but then it stops. It would have been better if it had gone round again, really, wouldn't it? 20. Right, okay, those look correct. What was it? 6987, 377, so it looks like that works as well. Yeah, so that's all well and good. We also get these next edit suggestions. So if you'll see at times little arrows appear at the side here as you're typing. So instead of just, completing the bit of text where your cursor is great, but sometimes you really want to look ahead. So if I change something, let's say we change the name of N. I mean, I know this is a refactoring you can do already in Visual Studio, but say number here, it will probably see that little arrow there, that's telling me, well, now that you've changed that, you probably want to change all these other things, so I can start tabbing away and accepting all these other changes. So it's now, this should still work. I think it should have caught all of them. So it still works, but it will, it's editing not just at the point where the cursor is and adding more code, it's looking further down the file and suggesting edits elsewhere in the file. So that is, I think that's everything for just trying to make sure I don't miss anything as I go through this. So the next thing we can look at, let's go back to our slides. So that's code completion. So that's been around for a while. That was sort of what was in the original product. Then they added Copilot Chat, so that takes it to the next level. So it's all very well predicting the next bit of text, but maybe you want to ask a question and have a little conversation with GitHub Copilot, and that opens up all kinds of new possibilities. So we can do things like ask it to explain some code. If we get some code that's written by somebody else, can you explain it? Do some refactoring, do a code review. What do you think of this code? We can generate documentation from it. Create unit tests. Who enjoys writing unit tests? Just get GitHub Copilot. You enjoy writing unit tests. I mean, it's a good practice. You must be a good developer. You must have very good code. But unless you're doing test-driven development, of course, in which case you write the unit tests first, which is another thing. But but if you want to retrospectively add unit tests, heaven forbid, who would ever do that? Then you can just ask Copilot to do it. Fixing mistakes, so you can just tell it to fix something. Not going to say it's going to work every time, but a lot of the time it can do the fixes for you. So let's have a look at GitHub Copilot Chat. So here I've got GitHub Copilot installed. By the way, it should be there. A couple of things you've got to do is, and it depends which version you got. So I'm on Visual Studio 2022 17.14. I think the minimum is 17.10 in order to get all these features. But 17.14 I think is actually the latest one. I did update it fairly recently. And somewhere down here there should be a in the where do they put it? GitHub Copilot here. That obviously needs to be checked. Now, I think from the more recent versions they are checking that by default. But if you have an older version, it might not be checked. So you might have to go in there and check that to get GitHub Copilot in Visual Studio. So I don't need to make any changes there. And then I get this. So if you can see this, you've got it installed. And I can say, open the chat window. So we did inline chat. So inline chat, if you remember, that's where you go in here and you say, you get a little mini chat window right in the context of what you're doing. And you've got all these commands to say, there's some pre-built commands to save you a bit of typing. So you can say /doc. So I can say document this. And it will generate a bit of over-the-top documentation, probably more than we really need. I think I'm going to, what's discard is Alt-Del. Where's the Del key on here? Oh, well, I'm going to keep it because I can't find it. It's quicker than trying to find the Del key. You can also do that from here as well. So I can say these / commands. So doc explain is another one. Explain the code in program.cs. And it'll start analyzing it and saying this, I mean, it's not a very difficult program, but the C# program generates and prints the first n numbers of the Fibonacci, and it goes on and on in some detail, actually, even though it's only a sort of a 20-line program. I can also say fix, so let's sabotage this. Put something. I wonder if it'll pick that up. New string. Okay, and we'll say, yeah, that's a good one actually. What was that before? That was 0, wasn't it? We'll say fix. That's actually a syntax error. But we can just, rather than use our valuable brain power, we can just get the, not sure it's done the right thing. What's it changed? So now I see side by side what it's done. Where was the change? It was up here, was it? Yeah, here it is. So it changed new string number to new int number, which is correct. So it's actually put it back the way it was. So the fix has worked. So I will, now you get to keep or undo that. So whenever it, this is in agent mode. Sorry, I didn't mean to show agent mode yet. Let's do ask. Okay, let's undo that. Let's do this again. So I'm going to say /fix. So forget you saw that. So fix the errors in program.cs. And it will go off and it will describe to me what I need to do. And it will go down here and somewhere it says the error is caused by initializing an int array with a new string. It should be an int number to match the declared type. And I can actually then apply, and it will then, it's another feature, and then it'll do the change, and I can tab to accept it. And now it's all fixed, and it should all be working again. What else have we got here? We've got /optimize. We could, might be able to improve the code. I'm not sure there's much to optimize here, but you know, if you're like me, a bit of a stickler for getting the last, you know, because you've you've lived through a time in your life where every computer cycle was precious and every byte was precious. So you want everything to be as compact and efficient as possible. And now nobody cares because it doesn't matter. But if you want to, you can optimize. And what else can we do here? What's the last thing? Tests. Oh yes, definitely want to create some unit tests for this. So create some unit tests. Now it's going to go off and create a unit test project probably. Or rather, it's because I'm in ask mode, it's going to tell me, here's what you need to do. You want to create a program tests.cs using XUnit. Now, I'd have a bit of work to do here. I'd have to install XUnit and all the rest of it. But it's telling me what I need to do. So those are the slash commands. Let me clear this out. When you start, you get this very helpful, very modestly says, I may make mistakes, check for accuracy, which is good advice, and suggests a few possible prompts you might put up in there. You can also do things like say, if I want to refer to something in particular, I can say the whole solution or just this file. Generally, if you don't do anything, it will look at the file you've got open and any other tabs that are open. It probably will, look at those as well. So, you don't need to be thinking, I must keep this tab open so that it looks in it. You'll just naturally have relevant files open, and so it just tends to work without you having to really think about it. But if you do want to be more specific, you could say, look at this file, or tell me something about this file or this project within the whole solution. We can also say there are some extensions here, so I can say, ask about the workspace as a whole. What does this do? It's going to be the same, actually, because there's only one file, isn't there, in the workspace? Not a very good example. Of course, it's a. Oh, you see, we knew that already. And you can also attach content. So you can say, this is quite interesting. If you've got, say, a wireframe or something, and I'm not really doing front end stuff today, but if you want to do design your front end and you've got a wireframe or even a flat design, you can upload that as an image, and GitHub Copilot will use that and do a little bit of front end work for you as well, which is incredible actually. Right, so what have I looked at? I've looked at the GitHub. You can look at I haven't got. I can say at GitHub, what is commit status? Actually, this isn't. We've got no source control at all here, so it should say. I think it'll either say you're not connected to source control, or it might say just give us a sort of a general. A general discussion about what is a commit status, what is commit in GitHub, in Git. Right. We can also choose the large language model. So you've actually got a choice here. So it's using GPT 4.1, which is sort of OpenAI's current best, newest and best large language model. And actually, it seems to be about the best for this. And I would stick with that. That's the default. And I would stick with that. You could use an older, GPT-4o is a slightly older model. So some of these, the 03 Mini is a smaller one. If you were wanting to keep costs down, so bear in mind, if you've got the free version of GitHub Copilot, you might start to use resource, and that might be a way. You might find you can reduce your costs by using a smaller model. But honestly, I suspect it's not worth the effort unless you're really desperate to squeeze every last. I would just pay for a pro license. Probably would make more sense. There are also other models, ones from Claude and Gemini. I haven't really tried these. I've just mainly stuck with the GPT 4 and 4.1, but they are available. There are some people think that this one, Claude Sonnet 3.7 Thinking, is better for doing some sort of analysis thing because it's got better reasoning capabilities because of the way that that particular model's been trained. I haven't noticed any particular benefit in using these other models, but your mileage may vary. It depends what you're trying to do. But there's no sort of best model. But GPT 4.1 I've found has been consistently fast, which may be a reflection of the hardware it's running on rather than how fast the model itself is. So that's you can choose that. You can also pick from this little booklet of pre-built prompts as well. Create unit tests. Document these do much the same as those sort of slash commands. So it's worth knowing all these things exist because they can save you a lot of time. And it can also do things like it can say if I've got a larger project. In fact, let me open a larger project. Let's use this one. I'm not going to bother to save that. And I can say, let's, what we're going to do, workspace. What does this do? And it'll go off and analyze all that code. And you can see the list of references it's picking up, and it says this defines a C# class called dictionary that produces a dictionary lookup intended for use of the Microsoft semantic kernel partitions, and then explains everything that it does. And I could also do please code review. Let's see what it does if I ask it to do a code review. So this code is terrible. Here is a code review. It goes on for quite a while. The code. Separation of concerns. The code is modular with clear separation between reading files. Can you read that all right at the back? I'm sorry, I'm not quite sure how to make this larger. Can I scroll it? Oh, that's worked. That was easier than I expected. Right, here is a code review. The code is modular with clear separation. Oh, nobody's said anything like that about my code before. Command line supports flexible, useful console logging. And then a bit further down, it'll, found a few issues. I ran this earlier, and it found a spelling mistake, actually. It was in a comment. No, actually, it wasn't in a comment. It was in a text string that was outputting, and there was a spelling mistake, and it spotted it. Suggestion. Somewhere it mentions a few kind of magic constants that probably should be variables or even input parameters. Using statements, good suggestion. Use using statements so that if for better control of resources, for disposal, wrap the main processing loop into try finally block to ensure cleanup. Yeah, they're all good suggestions. And I could then say, I could actually say, please, how should I implement them? And you tell me exactly how to do it if I wanted to. Right. So that's what have we looked at now? We can create a method to do X. Yeah. So we could say, let's say. I'm going to just delete something here. Let's move this out of the way. Maybe can make this a bit bigger as well. Not quite that big. I've got a function here called load word list. Now this function, load word list, I entirely wrote using GitHub Copilot. That's not quite true. I did have to make a couple of little changes. And what this does is it reads this file, which is actually a TypeScript file with a lot of words and definitions in, but it's a TypeScript export. So export const definition z equals that, and then a long list of these strings, which are a word followed by a definition and some pipe characters to separate them. And then at the end, it's got a closing square bracket because it's actually a JavaScript object. And what I would like to do is have that as just a big collection of words. So all I did was I made sure I had that open, and I said, what I want you to do is pass this file and give me a list of words. And it came up with pretty much all of this. There was, actually it was word list. It was the word list I was loading from, which is slightly different format. That's just the words export and a comment at the beginning. And then at the bottom, it's just got a little bit of extra stuff, which is this list of this partition index object at the end. So the only problem was it picked up all these as well and thought these were words. So that was the only change I had to make, was tell it to stop when it saw this string here. So that bit there, test, if line contains export const partition export partition index, that code is mine, but everything else was automated. So when it goes through and so we could probably do this again. So I could go in here and say, let's delete this and say, could say implement the function load word list, and then I'd have to tell it, I'm not going to do it now because we're probably going to run out of time, but it would then I'd then tell it exactly what I wanted it to do, but I'd say use this file wordlist.ts, and then it would see the file, figure out how to do it, and generate the code. So let's just put that back the way it was. Right. Now, one last topic is, so chat is great, but now we have agent mode. So agent mode is where it will actually, instead of just telling you, here's some nice code you can paste in, it'll actually go and do it, and it'll actually modify your code. Not only that, it'll do things like it'll run command line scripts and things like that for you, and it'll talk to GitHub, and so it's able to do a lot of things, database migrations. You know, it can do a lot of things that you'd be sort of manual grunt work, which you'd have to remember, either remember how to do, or you'd have to look it up and say, okay, with this particular database engine, how do I get it to populate it with some initial values or something like that? So this is where agent mode comes in. So if I go here, I can say, switch this from ask to agent, and now it's in agent mode, and so now if I were to say fix something, it would actually go and do it in the code. Now, in order to get agent mode in Visual Studio code, in Visual Studio, you do need to go to settings, GitHub, This might change actually. So this is at the moment, this section in settings just has the one Copilot. I think they're going to break that up because I've seen demos where they broke this up into different sections. This might be unchecked in your instance of Visual Studio, depending which version you've got. I think the newer ones, I think they're enabling it by default, but the older ones, you will actually have to go in and check that box to enable it. Once you've got agent mode, you can start to do interesting things. So let's go and we'll if you make some changes, let's say what can we tell it to do? Well, we'll do a file, new project, and we'll make an ASP.NET Core web app using MVC, and I'm going to call it Web Application 3, create, and I'm going to go into here. What does it say function there? Is it because of the scrolling of the yeah, I think it is. Yeah, okay, that's better. It's a sort of a zoom scroll artifact. Right. So what I've got should be a model view controller. It won't be very exciting, but I've got a program.cs, var builder build, blah, blah, blah. Use static files. It's got models. Nothing really there very exciting. Home controller. If I run this, it's going to say, probably going to say HTTPS certificate, is it? No, it's running. Right, so the usual starter application. So now what I can do is I can do something a bit more interesting. So I can say, let's go to GitHub Copilot, and I'm going to say, and I'll just make sure I get the, please update, because I'll miss something out if I don't do this, update, and we'll wait a lot of time. The application, application to have a database using SQLite. How do I spell SQLite? The database will be pre-populated with 10 popular operas with name, composer, and date of first performance. Right. I think that's enough. I've said it. Create it with a SQLite. It's going to be pre-populated with 10. Right. So I'll do that for now. In fact, I'll do this now. I'll say the operas should be listed on the home page. Okay, now this is a risky demo, this, so anything could happen here. Right, just want to see that and say, and I've got agent mode on. I'm going to say go, and we'll see what happens. So I'm just going to zoom out a little bit, otherwise we can't really see much here. Not that much. Just give me a little bit of room to play with. So here's the plan. So it's not just doing one thing, it's kind of come up with a whole strategy to how to do this. Add entity framework. EF Core, good choice. And SQLite support to the project. And if we look down here, we can see it's actually doing stuff. It's gone and installed some NuGet packages. Oh, it's done all sorts of the stuff down here. Mainly installing NuGet packages. meanwhile, what's it saying here? It's saying create an Opera model, create a DB context, configure the DB context in practice. See, this is all changing here as it goes. Still going. Add code to see the database with 10 popular operas. Update the homepage to list the operas. I will start by searching for existing models. It's got some code snippets. There is no Opera model. Here's what I'll do now. God, so when they've trained this, they've sort of trained it to use a sort of a chain of thought, which is a common approach in trying to get large language models to sort of think logically. And by chain of thought, you say, tell me the steps that you're going to do, and then you give it examples of how to do this. And then it starts, if you just say, do this thing, it sometimes just goes off at a tangent or does something random or it hallucinates. But if you say, tell me the steps that you're doing and this is how you do it, it's usually much more successful in following doing a sort of a logical set of paths as we would do as human beings. So this is why saying I'm going to do this, and this is because it's been trained to do a sort of a chain of thought way of mapping out its logic or doing a plan of what it's going to do. I think it's might have finished actually. I'll begin adding the DB context. So you see here it's done. There are various steps that it's done, and you can actually see a list of the changes it's made here. And you can choose to keep or undo them. I'm just going to keep them because it's just my first attempt. I can just nix this whole thing if it goes wrong and start again. I haven't invested a huge amount of effort in it, but somewhere up here there will be, if I can find it, there'll be a checkpoint as it went through. There should be there, that checkpoint there. If I don't like what I see, I can actually, it's kind of got a memory of where it was before, and I can get back, do a massive undo back to where I was before. But meanwhile, what's happened here is let's see what the code looks like. So we've got an opera.cs somewhere. I'm hoping it will have populated some. Maybe this DB initializer will have some initial. There, look, that's all come from the large language model, the names of these operas and the dates. La Traviata, Turandot, composer Puccini, first performance 1926. I'm pretty sure that's correct. So that looks good. Now, does it work? That's the big question. No, it does not, because it says... now, I might be able to fix this. See if we can figure out how to fix it. Because, to be honest, I haven't given a lot of thought to this code. Just let it run. And maybe, what's it done? I don't know. I'm just going to... I don't have time to start debugging it, sadly. Let's stop this and see if I have another go at running it. All right. Okay. Here's one I did earlier. I knew this would happen. In the interests of time, web application 2, I think, which I did earlier. I think this one works. That's where we should be. So I did the same process. I actually did this one. The reason I think this worked better was I did it in a two-step. So the first step I said was create the database and populate it. And then as a second step, I said, and now put put it on the home page. And then it did the code to do this. I think I just tried to do too much in one go that time. I was hoping it would work because it would save us a little bit of time, but it didn't quite pay off. All right, but it has installed SQLite. It had in the other project. This one, this has done the same thing. So I can see dependencies, packages. I've got entity framework. I think it's got SQLite somewhere, and there's the operas.db. That's the SQLite file. SQLite's like a file-based database. And somewhere in here it'll be doing the calls to do the SQL into the SQLite database. Just one last thing. Let me just do one. See if we can get this to work. Is where's the thing got file? Let's create another folder. What's this thing? Let's lose this. Stop all this. That's stopped. Let me just do something a little bit different. I will go up a level, CD. Make directory operas, CD operas, and open Visual Studio Code in here. And yes, I trust the authors. And I had a prompt which I put inside here. Let's see if I can find it. Yeah, please. That. A text here. Let me just open. Just make sure is it actually text. Copy. And then I'm going to say Copilot chat. That's in agent mode. Please create a React web app backed by a SQLite database. Database should be pre-populated. So this will probably end up doing even more. Again, I haven't told it which technology to use, so it's freewheeling on that. I would put something in the instructions if I wanted to use a particular technology, or I'd put it in the in that. So there's a master file that it uses. There's a file under GitHub. See if I can find it. Under the GitHub directory in which one were we on? Projects AI. Which does demo 5? Not that one. Which one am I on? Operas 1, I think, has it. This file here. It's called Copilot instructions.md, and you can have other files as well, or you can tell it, say, use this file. That can be one of the files that's anything very interesting in. I can do something like, let's do this. If we want to have a, go into GitHub Copilot chat and say, please create a .github Copilot. What's the file called again? In Copilot-instructions with best practices or something like that. And it'll give me a starter file. So I can actually use GitHub Copilot to create the sort of instruction file. And that should give me a good starting file. Is it doing it? I would expect to see it here in a minute. And it will create a set of instructions, and then you can go in there and fine-tune it and tweak it just like you want. So if you've got, here we are. Oh, it already exists. Oh, okay. Well, here they are anyway. Here are the instructions. So you can say, these are our best practices. Well, they may not be your best practices, but you can change them. And then you say, right, these are our best practices, we'll use this. And then you can say, please review my code according to our coding standards. And it'll do all that for you. All these tedious jobs that it can do. Meanwhile, back over here was Opera's. What on earth has this thing been doing? It said, now it will give a few prompts where it's going to do something drastic, so it wants to ask you first. You can dismiss it and say, don't ask me again. So it says, here's a high-level plan to create your React web app. Scaffold a Vite-based React app. Set up a backend Node.js Express with SQLite. Connect the React front-end API. Ensure all starts. So first of all, it has to do npx. So I'm going to say continue. And it's off here doing npm install, npm run dev. No, done now run, it says. It can't have finished yet. npm install it wants to do. God knows what it's installed. Okay, is this a good practice? Let it do something and then that? No, but it's an interesting demonstration. I would recommend staying in control and watching what it does. But it's interesting to see, oh, look, it's created a package JSON. What are we, I want to keep. It's now asking me if can I do this? Yes, you can. And again, I might have asked it to do too much in one go. Got the 6 million NPM warning messages, as usual. They're still working. Right, while I'm going to let that churn away for a little bit longer. Let's change the Copilot instructions MD. I think it's just put this is what this app does or something in there. Created the README. Ooh, we've got a README now. There's the changes. Keep. Yes, keep. I want to see the file. This project's a React app. Ooh, instructions. Open a terminal and navigate to the server directory. Do an npm install and npm start. Maybe we should try that. What have we got here? Right, cd server npm install. I think it's already run that. npm start. So it's started some kind of back end on port 3001. I need another window now. I can do that, can't I? Now, where was I? CD projects, CD AI, wasn't it? And then finally CD operas. And then what's the instruction for the other one was, I've lost the instructions now. Where were they? Oh yeah, here we are. In the project root, run npm install npm run dev. Right, okay, we'll do that. Npm install should be all there, but we'll run that anyway. And npm run dev. Starting something up on port 5173. Let's have a look, see what we've got. So on port 5173, a list of operas served from a web server, which is then talking to a back-end database thing. God knows how it works, but it does. Turandot, Puccini, 1926, all good. And its knowledge of operas is excellent. So I think that was everything I was going to show. One other thing was so remember I mentioned tools So this is down, come back. Down here, where's my mouse gone? This thing here is select tools. What you can do there is, so you see it's talking to GitHub Copilot. So that's actually using MCP, that's Model Context Protocol, which is a protocol for talking to some back-end system in order to provide a sort of tooling support or function calling for your large language model. So that's how it talks to GitHub. And this is what the MCP JSON file. So you don't need to do it for GitHub because they've already done it for you. But if you did, you'd create an mcp.json file that's got any tokens you need. Obviously, don't put them in the file and then source control them. You know, protect those tokens. Perhaps put them in an environment variable or something, or in preferably in a key vault. But this tells it how to talk to GitHub. And then the function calling mechanism will be able to call into GitHub. And that's how it's able to do this here and call GitHub. And then this is where you can enable or disable the individual tools, so that effectively the individual functions that are available from that GitHub endpoint. So if you talk to some other service, like you have some proprietary database system or something like that, but you want to be able to talk to it, then you can use, and it's available with an MCP server, then you can use this technique to get to those tools as well. So this is a way of adding more tools, or some other source control system, for example. So that's MCP and adding tools. So I think that's going to wrap up there. I'll just say, just be aware of the limitations. So, you know, I've gone through and kind of be fairly gung-ho about using some of these tools, but they do have limitations. They can still hallucinate, and I find in practice about 50% of the time it generates code and it's absolutely fine and I can use it. And the other 50% of the time I've got to go in and do something, or that's not what I meant, or it doesn't quite work, or there's errors and I have to fix them. Just be careful about your quota if you're using the free. There is a free version of GitHub Copilot. Then there's the 50% first-time success rate. Don't be afraid to throw away generated code. It hasn't really cost you very much. I know there's at the back of your mind, you're sort of thinking it could have come up with some brilliant algorithm, and I've just thrown it away. And you've also got to watch out for accidental plagiarism. It has a mechanism in there that should warn you if it sees some code that is generated that perfectly matches something that's publicly available. So it will make an attempt to warn you about that, but it's not totally foolproof, but it should mitigate that problem. If you're not confident about agent mode, you can use ask mode. There's also an edit mode in Visual Studio. Visual Studio Code has an edit mode. I think they've dropped it from Visual Studio because it's really replaced by agent mode. It was only there because there was only ask and edit, but now we have agent. We don't really need edit. But you can use ask mode, and it'll always say, this is what I suggest you do, rather than actually doing it if you're at all nervous. And certainly keep checking in and committing to source control frequently before you start doing anything too drastic. But you do that anyway if you're doing a refactoring or something like that. And remember that you're in control, not GitHub Copilot. Tell it what you want. Don't spell out what you want it to do. Don't leave it guessing. There's no advantage to that. Just tell it what you want it to do. There's a voice mode in the GitHub Copilot on Visual Studio Code. I don't know where it's gone. I thought it was on Visual Studio. I don't know where it's gone. I don't have it. But you can just speak to it if you know, to save typing if you don't like typing. But spell out what you wanted to do. Use that Copilot instructions file to give it, these are the parameters. This is what I'm trying to, but don't do what I did and just say, just use any technology you like. Tell it what you wanted to do and what kind of technologies you wanted to use and coding standards. If it makes a mistake, that can be an opportunity to revisit those instructions and put something in there to stop it making that mistake again. It'll get better and better at doing what you want it to do. But you can get rid of a lot of mundane, repetitive work using the Copilot agent mode. So I would recommend using it, but just with a little bit of caution. Don't ask it to do too much in one go. So I think that's what went wrong with the example that I did earlier. I did a two-step. Then just now I thought maybe I can get away with doing it all in one go, and I think it confused it. So it's often better to do step by step the things that you wanted to do, and then don't give it too much because it's got much less scope to go off and get it wrong. And then, usually you will have the relevant files open in the IDE, but if there's something that you want to refer to that's relevant, like that TypeScript file that I wanted it to reformat, make sure that's open in the IDE. Or you can upload files into GitHub Copilot and say, here, use this file, use this image even of a wireframe or something. And it's sometimes a good idea in agent mode is to say, I want you to do this, this, and this, and nothing more. Stop when you get to this point. Otherwise, it might continue and do something you didn't want it to. And don't forget, you can write unit tests. So your development loop is now ask Copilot to do something, check the results, keep the changes, commit the code, and then clear the chat. So don't leave the chat all the previous stuff. That will confuse it as well. I would suggest clear the chat and then do the next thing that you want to do. So that's your cycle. Ask it to do something, check it, tell it to keep the changes or undo them if they're not right. Then do your commit into source control, clear the chat, do the next thing. Which would you rather use? A shovel or an enormous digger? I mean, this is the... It depends what you're trying to do. If you want to do something intricate and it's sort of artistic and you want it to be perfect and you want to be... maybe you want to do it with a shovel because you're doing... but if you're just trying to get a lot of work done, then a big earth-moving machine is probably the better choice. And that's the way I see it. It's not. It's still you in control of it. It's just a more powerful machine to do your development with. So treat it as a member of the development team. Prompt it. It doesn't make poor developers good developers, unfortunately. And it's really got to ask yourself whether you can afford not to use this as a tool. Right, now, just remind myself that I do have some swag as well. So I've got some stickers. Have you got stickers today? No, these are the only stickers today. So there's some Octocat stickers and some Microsoft Azure AI stickers with a sort of a network thing pattern on. And could you please, if you wouldn't mind, fill that form out. It's very short. You just got to say how fantastic it was so that they'll give us more swag. And I've got a couple of bits of swag, one for today and one for tomorrow, right, for York. So whoever wins, do you want to do the raffle thing for this as well? And then whoever wins can choose between the this rather splendid bag for sticking wires and things in, or this thing. This is the Season of Agents swag. So this thing is, apparently, you stick your watch, it charges your watch and your phone and holds them all together in a nice thing. I didn't fully understand it, but it looks extremely useful. And it's, it's got a sort of USB charging everything feature. So one of those, raffle one of those, Kev, and that's it. I've got some resources as well. So that's it. Thank you very much. Hope it was useful.